Hello, good evening, Alfred and your team. Hope all is moving well your side. We are doing fine. Basically, I think trying to continue with our work we started. We agreed that we shall be doing some weekly update, weekly knowledge sharing. I've not heard from you guys. It seems it's on a me sharing. I also want you guys to share something that will keep us busy. So I think at our start, that not introduced myself very well to many of you. I know there are more guys who are joining. I'm known by the names of Engineer Michael Jackson Ochola. I'm an experienced bridge and structures specialist with a Master of Science in Bridge Engineering, obtained from University of Surrey in the UK, Guildford. I've been in the field for over 22 years, and I've been exposed to a lot of modeling using different softwares, including Midas, loading, and analysis, designing with softwares, any other applicable stuff like Excel, manual, and the rest of it, and also managing bridges stocks, because when I joined Yondra difficult, it's more bridges and development project. I have proficiency in CAD software, including Midas Civil 3D, or Midas Civil, as they call it. And I'm also a registered engineer, licensed with the Engineers Registration Board of Uganda, and also a member of Uganda Institutions of Professional Engineers, and a certified project management professionals from Project Management Institute, USA. I've been involved in really major bridges and structures project. Some have been concluded, some are already operational, others are still ongoing. So basically, as we continue to interact, you will be seeing the details of what I've been involved in. Why am I doing this presentation? Basically, the purpose of presentation is to share insights, practical knowledge, and innovative approaches related to design of reinforced concrete box culverts using Midas Civil 3D. I remember last time when we started, we were hinting on reinforced concrete. I think we handled slab bridge. I know after this box culvert, we shall move to at least concrete girder. One, it will be, I think the concrete girder will be when it is propped within 15 meters, and then we shall also do the one that it is not propped. You precast in the yard, and then you lift, and then you cast where fresh concrete, and you allow it to set, and then you load, which has construction loading, construction stage loading. So that will be what we shall be doing after our this stage. You are expected to learn about best practices, modeling techniques, and effective project management strategies in the context of box culvert. I think we already started hinting on challenges, construction practices. I've been sharing with you some photos that can reveal insights of what an engineer should actually do for your design to be functional. So you have seen some of the foundation getting submerged during construction. What as an engineer, what would you do? So what are those special attention you need to attend to? Then the expertise and experience of the presenter will contribute valuable information to you, making the knowledge sharing session very good and learning opportunity to becoming good professional in the industry. Basically, I think many of you can now attest to that. You can talk eloquently with confidence about bridges and box culvert, and I'm proud of you young guys. Let's continue, and then you enjoy the industry. An overview of box culvert. Basically, you guys have read it is it's a buried structure that serves various purposes, such as conveying water or providing underpasses for pedestrian or animal. Modeling of box culvert in Midas Civil. Box culverts can be modeled using different element types. You can do shell, you can do plates, you can do solid, and then boundary conditions. You can do rigid springs, or you can do rigid foundation or flexible with spring constants, and then also fixing certain point with the not to allow movement during load response, and also the different load types, the traffic, the surcharge, the hydrostatic, temperatures, shrinkage, so many things that you learn. Now, always is very important that you understand the material component. That's why now the concrete material, the compressive strength, the reinforcement materials, unit weight, all that you need to understand. You need to know about soil fill unit weight, and then also the backfill, angle of internal friction, but it always varies. It's not 30. This that I've given you there. And also you need to look at water unit weight is important, because hydrostatic and also the weight of water, if it is submerged, also can be taken. So this soil weight can be when it is submerged or when it is dry. And then the coefficient of subgrade reaction, it varies. I got this literature from some other text, but it is very important that I've even told you coefficient of subgrade reaction is the question of soil pressure over allowable deformation. That is the bearing capacity. If you want to make shortcut, divide by the allowable bearing capacity of the box. This is about 20 to 25. So you get that in kilonewton per cubic meter. That's what you always do. Now the geometry is very important. You have to know the plan view, the length and the width, and the length is determined by the backfill, the embankment fill. That one I think we shall be sharing and look at it. The barrel sizes you need to understand. I think there's a typical example. That's why I've given you 5.4. The top slab thickness, the bottom slab, the wall thickness, inches, reinforcement, clear cover, the height of the field. Those are the things you need. This one's 817. I think there was a typical project, so I picked some typical example. Boundary conditions and modeling in Midas. For the boundary condition of the box culvert structure, calculate the coefficient of subgrade modulus of the rectangular foundation and apply it as a surface spring support feature in. I've given you that. That is the spring constant, the bearing capacity divided by the allowable deformation. That's what you see here. The literature is saying the coefficient of subgrade reaction depends on the foundation dimension, length and width, and soil property. Definitely, of course, now as you go deeper into your geotechnical engineering, you will get to know some of the things. On this, on the right here, you can see that if you open Midas, you will see when you are going to handle now that the start point is where it is frame and box, reinforced frame and box culvert. So when you enter there, you are going to find areas where you do box culvert and how many spans, and then from there it gives you all that option, and you are able to start the whole thing. Now setting up the domain and subdomain, I told you also that because you have to design at the end of analysis. So you have in domain it will be the box culvert, and then when you come now to the subdomain, it will be the top slab, and then you get the bottom slab, apron slab, the wing, and then you go to the wing walls are the vertical plates, or what they call the plate column, while the top slab and the bottom slab are the plate beams. So that is what you need to, you first define this at the modeling stage. Then when you run the analysis, you should be able now to, when you go to design component, then you are able now to provide the detail required. Then defining the material property, concrete reinforcement is very important. I think we shall have to have a session where we shall be doing all this. I will demonstrate, actually I will demonstrate this. So let me just take you through. So defining material property includes concrete grade and rebar strength as required for the particular project. Grades of materials can be influenced by exposure factors and loading condition, among other factors. Please take note. I've also told you your exposure, you may have a level of acidity too high that can initiate corrosion in the earliest, and yet your box culvert is designed for about 100 years. So within 20 years, you'll start finding challenges because you find that your exposure condition was harsh, and then you went on with a nominal cover. So, and then the concrete grade. So those are dictated. Take note of that. Creating the geometry of the box culvert, slab, thickness, everything. When you must know that this is created from, you start from here. This is where you define all you require. I will demonstrate that. You specify, you know the top slab thickness, the bottom opening is already given to you by your hydrologist, and then you start now, and then you have also done preliminary thicknesses depending on the span, and then you're able to do all this. Load application, the loads applied on box culvert are integral consideration in their structural design. There is a clear distinction between the permanent actions and variable actions, which play a crucial role in shaping. So with permanent actions, you can now read all this. Dead load constitute the inherent weight of box culvert, such as base slab, wall slab, top slab. Then superimposed dead load are now the one you apply after you have constructed your box culvert. Horizontal earth pressure also come in as a later, and then you apply because the concrete must first set and harden. Hydrostatic pressure also you have to do, such as from live load and other things. Variable loads, last time I shared with you this graph on the right hand side. It is basically traffic, and it is very important to note that as the depth of fill increases, please note that the axial load dispersion force or the axial effect reduces as the fill increases up to a certain point where the dead weight takes precedence. Take note of that. The analysis of box culvert, these are the output you get from your software. You should be able to get look at that, read this, and then read other texts I think I've shared. Make sure you get all the perform static analysis, moving load and assigned boundary condition, load cases, and you're able to do that. Designing a box culvert, this is now where you have to, we shall also look at there's the design component that you will open, and then you follow all that is required. That is very, very important. So this is what happens when you do the design. You get output, which output, if there are failures, please, you go back, iteration, correct areas, reinforcement type, reinforcement sizes, spacing, cover, all that need to be improved. And these are the different things. You can see this is a run-on slab, there's no fill. This is now the middle ones, the different loading component that I shared with you, what they call load path is very important. You have to know load path. Then this on the right hand side here, this is now where you have a fill. This is where the 817 was. It is a 5x4. Horizontal is 5, vertical is 4. So all this soil parameter is given by the geotechnical people, and your work is now to get all these parameters and start the modeling. That is where I think I decided to share with you the narrative. Please read as widely as possible.